Hello everyone, this is Vijayalakshmi Sugnali from WinMaths YouTube channel. WinMaths is a free YouTube channel helping students across Karnataka to excel in their PUC board exams and various competitive exams. This channel helps to those who are studying PUC and guide you in making a PUC preparation for various exams. Let us discuss the concept, relations and function for second PUC students. In our previous classes, we discussed the definitions of relations and some basic concepts, and also we will discuss the types of relation. Based on the types of relation, we already saw some example based on the definition. Now, let us move on the exercise problems here. Okay, before going to solve exercise problem, we will recall the definitions. Okay, one by one. Here there is a first one definition is type of function is reflexive. Okay, now what is the definition of reflexive relation? If an element of A is related to the real image or itself. Okay, if A be an element, it is related to itself only for every relation R. Okay, then for every element of A is belongs to the set A. Okay, here A be any set, an element which is belongs to set A. This is called reflexive. Again, the second one type is symmetric. If an element, the first element A is related to the second element, or else A is related to an element B, which is belongs to the relation, then it is related to B to A. Okay, A is related to B means obviously the second is related to first element. This is which is belongs to the relation R. For every an element AB belongs to the set A. Then for transitive relation, if first element is related to second element which is belongs to R, and the second element B comma C which is belongs to the relation R, then the order pair of the first element is obviously related to the third element. A is related to C. Okay, this is called the transitive relation for an element A, B, C which is belongs to the main set A. Okay, when these three conditions are holds, then it is called it as a equivalence relation. Okay, now discuss the exercise problems here. Okay, here there is a first question. Determine whether each of the following relations are reflexive, symmetric and transitive. We have to check the relations, that is reflexive, symmetric and reflexive. First, we have to check the definition or else relation of the given function. Here, A be a set containing the elements 1, 2, 3 up to so on for 13 and 14. Based on this set, the given relation R is equal to the order pair x comma y such that 3x minus y is equals to 0. Okay, the relation can be given in an equation form. We have to write the, or else we have to solve the equation. Based on the equation, we have to write the order pairs. Okay, so first relation is equal to, I will consider x first. I will consider the equation 3x minus y is equal to 0. We will take one by one elements here. First, I will take x is equal to 1. Then we have to find the value of y. 3 into 1, 3 minus y is equal to 0. So the value of y becomes 3. Similarly, for x is equal to 2. Then 3 into 2 minus y is equal to 0. 3 2s are 6 minus y equal to 0. Then the value of y becomes 6. Again x is equal to 3. 3 into 3 9 minus y is equal to 0. Then y becomes 9. Similarly for x is equal to 4 and on 3 into 4, 12 minus y is equal to 0. Then the value of y is equal to 12. Similarly, for x is equal to 5, then 15 minus y is equal to 0. Then y becomes 15. Okay. Now, I will write the order pairs here. That is, if x is equal to 1, then y becomes 3. Okay. X is equal to 1, the order pair y becomes 3. Next, x is equal to 2, then y value 6. X is equal to 3, y is 9. X is equal to 4, then it is 12. Then we don't have to consider here x is equal to 5 because when we have to take x value as a 5, then y become 15. 15 is not present in the given set. Okay, here 15 is not present in the given set. That's why we are not consider the order pair 5, 15. Here only the 4 order pair for the given relation. Now we have to check the three conditions, that is reflexive, symmetric and transitive for the order pair of the relationship. First one is reflexive. According to the definition of reflexive, if an element has to the related to their image, but here or else since the order pair 1, 1 not belongs to R, similarly 2, 2 not belongs to R, and then 3, 3 not belongs to R, up to so on for the last element 14, 14 not belongs to. Hence, R is not reflexive. Again, I will consider the second one, symmetric relation. Here, according to the definition, here, since the order pair 1, 3 is belongs to R, but 3, 1 does not belongs to R for every elements of 1, for every elements of 1, 3 belongs to the set A, but 1, 3 belongs to R, 3, 1 not belongs to R. Hence, R is not symmetric. Now, let us consider the third one, transitivity or transitive relation. Here, 1, 3 belongs to R and 3, 9 belongs to R. But the order pair 1, 9 does not belongs to R. Okay, that's why R is not transitive. Okay. Therefore, what we say finally, the given relation does not holds the reflexive, symmetric, and transitive relation. Transitive relation. Okay, hence the proof. Now let us move on the second one question. Relation are in the set of natural numbers defined as r is equal to x comma y such that y is equal to x plus 5 and x is less than 4. Okay, here they given a condition. Okay, or else they given a set n be a set of natural number. N be a set of natural number. We already know that the numbers starts from 1. Okay. Set of natural number means the number starts with 1, that is 1, 2, 3, 4, 5, 6 up to so on for infinity. These are the set of natural numbers. Here, based on the natural number, I will define a relation that is x comma y such that y is equal to x plus 5 and the value of x is less than 4. Okay. Based on the relation, I will define the order. The first one, I will take the equation here, that is y is equal to x plus 5. Now, put x is equal to what? Y becomes 1 plus 5 is 6. Again, x is equal to 2. What is the value of y? 2 plus 5, that is 7. Then x is equal to 3. Y is equal to 3 plus 5, it becomes 8. Okay, here I will consider x value only 1, 2, 3 because they mention a condition the value of x we have to take less than 4 up to 3. The natural numbers and the numbers are less than 4 only. That's why here I will take x is equal to 1, then the y becomes 6. Similarly, x is equal to 2, y becomes 7 and x is equal to 3, then y becomes 8. These are the order pairs of the given relation. Now, we have to check the condition one by one. The first condition, reflexive. While observing the order pairs of the relation, based on that, we will define if 1 comma 1 does not belongs to okay, or else I will write since here since 1 comma 1 does not belongs to R, therefore R is not reflexive. In similar manner, check for symmetric condition. Here 1 comma 6 belongs to the relation, but 6 comma 1 does not belongs to R. For every 1 comma 6, for every 1 comma 6 belongs to R. So or else 1 comma 6 the elements which is belongs to the set A. Okay, that is set of natural numbers. Now, third one condition, based on this, R is not symmetric. Third one condition, transitivity. Here, here, consider 1 comma 6 belongs to R. Okay. 1 comma 6 belongs to R. Here there is a one special case here. If there is a only the order pair containing the elements 1 comma 6, 2 comma 7, 3 comma 8. While observing the order page, there is no common element related to here. Okay, the domain and codomains are different. If there is a only one order pair present, that time it is transitive. Okay, it is transitive. This is the transitive. This is the special case. Okay, if only one order pair is present, then obviously it holds the transitive condition. Okay, this is one of the exceptional cases. It is possible only when the order pair, domain and codomain both are exactly different elements are there. Okay, if here there is no one element is common to the both set. Okay, that time if only one order pair is present, or else there is no connection between any two sets of the order pairs, that time it holds the transitive condition. It is the special cases. Okay, therefore, what can I do? Or else what can I write? The given relation holds. The given relation holds transitive, but neither reflexive nor symmetric condition or symmetric relation. This is the solution of the given problem. Okay, the given relation holds the transitive property but does not, or else neither reflexive nor symmetric. Now let us move on the third one, question one. Before going to take the condition, I will write the set containing the elements 1, 2, 3, 4, 5, 6. Okay, and the relation I can define here x comma y such that y is divisible by x. It means in generally I can write y divided by x. In generally what can I write? Y by x. In this form, whatever the elements of the form y by x, it is divisible. Now the completely it is divisible and the result we will get as a whole number. Okay, that time y is divisible by x, satisfy the condition. Now we will check the condition one by one. Reflexive. Okay, since every element is since every element is divisible by itself, every elements or it since every element is divisible by itself, So completely divisible by that itself only. So x comma x belongs to the relation R for every x is belongs to set A. Okay. Therefore, it is a reflexive. Similarly, for symmetric condition, let x comma y belongs to R. Okay. Here, let x comma y belongs to R. Now, then y comma x does not belongs to R. If I consider different elements, for example, here 2 comma 4. I will consider any two elements 2 and 4. The elements 2 and 4 I will consider here 2 comma 4. Okay. It means 4 is divisible by 2. X comma y. Here also x comma y such that y is divisible by x. That is 2 comma 4. 4 is divisible by 2. I can write here 4 by 2. 2 ones are 2 twos are. The answer we will get as a whole number. It means the element is divisible by the given number. Similarly, but while considering the elements 4 comma 2, okay, 4 comma 2 does not belongs to R because 2 is not 2 is not divisible by 4. That is 2 comma 4. We will get the result 1 by 2. Okay, it is not a whole number. 1 by 2 is not a whole number. So it is not completely divisible by 4. Therefore, it is not symmetric. Next, we will check the third condition, that is the transitive condition. Now, let x comma y belongs to R. I can write simply y by x and y comma z belongs to R. So I can write here z by 5. So I will combine together both. So combine together both, that is x comma y belongs to R. That implies y by x. Again y by z belongs to R. It is z by 5. So I will combine together and I can write here y, that is z by y whole divided by y by x. Okay. By the second element divisible by the first element, y get cancelled. We will get the result z by x. So z by x I can write it as x is that is x is divisible by y. Sorry, y is divisible by x. So I can write x comma here z, that is x comma z belongs to R. Hence it is transitive. Therefore R is reflexive and transitive, but not symmetric. Okay, but not symmetric. Hence the solution in given problem. Okay, now let us move on the next one question. Question number 4. A relation R in the set Z of all integers defined by the relation R x comma y such that x minus y is an integer. Okay, here let us consider the set Z. Z will be set of integers. Okay, set of all integers. As we know that integer means it containing all the elements, that is plus or minus 1 including 0, plus or minus 2, plus or minus 3 up to so. Okay, now we will define a relation, that is R is equal to x comma y such that x minus y is an integer. Okay, here I will consider the relation 1 reflexive. Since 1 comma 1 belongs to R. Okay, I will write as a order pair 1 comma 1. Then according to this relation 1 comma 1 such that here 1 comma 1 such that 1 minus 1 is an integer, right? Yes, because 1 minus 1 we will get a 0. Okay, 0 is an integer. Obviously 0 is an integer. When you take any element is related to itself, then you will get as a number 0. That is, the difference will be 0 is an integer. Therefore, it is reflexive. Again, second condition. If second condition, that is symmetric. Here, I will consider x minus y is an integer. Okay, x minus y is an integer. I will take minus as a common from this one, that is minus. By taking minus as a common, then y minus x is an integer. Yes, obviously, because the integer containing both the positive number as well as negative number. So I can write it as y minus x is an integer. Y minus x is an integer. So for this one, it is that for this one, I can write if x comma y belongs to R, then y comma x belongs to R. For every x comma y belongs to the set z, that is set of integer. Both x and y are the set of integers. Therefore, it is symmetric. Now, we will check the third condition, that is transitive. If I have considered the element a comma b, or else here we given x comma y. So first, if x comma y belongs to the relation R and y comma z belongs to R. Okay, here x comma y belong to R and y comma z belongs to R. So I can write here, that is x comma y belongs to R. It can be written as x minus y is an integer and y comma z belongs to R. That is y minus z is an integer. While combined together, while combined together, we will get x minus 5 plus y minus z is an integer. While adding both the integer numbers, again we will get the integer. That is, here while adding x minus y plus y minus z is an integer. So minus y plus y get cancelled. We will get x minus y is an integer. Therefore, x comma z is also belongs to R. Hence, it is transitive. Therefore, the given relation R is an equivalence relation. Because it holds the all condition, that is reflexive, symmetric and transitive. It holds the all the condition. Then let us move on the question number 5. Relations are in a set of a human beings in a term at a particular time given. Okay, here they given a relation of the human being. Based on that relation, we will check the condition, that is reflexive, symmetric, and transitive. Okay, I will check the relation one by one. For the first condition, I will take x comma y such that x and y work at the same place. Okay, here it is reflexive. Directly I am saying it is reflexive because if anyone is related to itself or himself only because he is the person, he is work at the same place, it is possible. Okay, most of the peoples are work at the same place only nearby their households. Okay, that's why the relation x is work at the same place itself only. Again, second, it is symmetric. Yes, obviously it is symmetric because because while considering x and y are any two people, okay, x and y are any two people work at the same place. Obviously, in an office, so many members are there. Okay, X and Y work at the same place means again while consider Y and X, both are the people working at same place. If you consider X is related to Y or else Y is related to X, if two persons are working at the same place, then again third one, it is transitive. Yes, obviously it is transitive because if two persons already working, X and Y is related to Y. Okay, if two persons are working at same place and another one person that is friend of Y. Okay, that is Z. He is also working at same place means X is colleague to Z also. If X is colleague of Y and another person Y is colleague of Z, obviously the Z person is colleague to X also. Yes. Okay. Based on the definition of the transitive relation, it holds the condition. Therefore, for the first one, x comma y such that x and y work at the same place is an equivalence relation. It is an equivalence relation. Now, I will consider the second relation such that x, y, such that x and y live in the same locality. Okay, same locality means here also similar to the first condition only. Same locality, same place. Okay, both are synonyms words. Same place or else same locality. Both are the synonym words. So it is also holds the above condition, that is equivalence relation. While solving, you have to write the definition, common definition for the condition to both. Now, third condition, that is third condition, the relation are x comma y. Okay, the relation are x comma y such that x is exactly 7 centimeter taller than y. Okay, so the relation reflexive condition is not possible. It is not reflexive. Okay, because no one is exactly has their image 7 centimeter. Okay, so when you when you see your image in mirror, That time also it is not exactly same. Okay, it is exactly 7 centimeter taller. It is not possible. Any one person, their image or itself is not a 7 centimeter taller than himself. Okay, no one is taller than himself. It is not reflexive because no one taller than himself. No one taller than himself. Okay. Similarly, for second condition, okay, that is symmetric. It is not symmetric. Okay, it is not symmetric. Why? Here, x is related to y, which is belongs to r because x has the height of 1 centimeter, then y is x is exactly 7 centimeter taller than y. Okay, sorry, here y is 1 centimeter, then x becomes 1 plus 7 is 8 meter. Okay, obviously, while taking in reverse order, that is y comma x. Now, y has the height 1 centimeter and x has the height 8 centimeter. Now, while comparing here, y is exactly smaller than x. Okay, y is exactly smaller than 1. Why? But it is not possible because our condition is x is exactly 7 centimeter taller than y means x is related to y, but y is not related to the same condition. Okay, the condition does not satisfy here. That's why it is not symmetric. Okay, let us consider the third condition, that is transitivity. It is not transitive. It is not transitive. It is not transitive because it is not transitive because here a person consider x comma y, the order pair belongs to a. X is exactly 7 centimeter taller than y. So x is an person is taller than y. Okay, x is exactly 7 centimeter taller than y. Again, while consider y is related to z, belongs to r. Okay, while consider y is belongs to z. Okay, so y is exactly 7 centimeter taller than z. Okay, if I will consider z as a 1 centimeter, then y becomes 1 plus 7. It is 8 centimeter. Again, while considering x, x is exactly taller than y. Of course, y has 8 meter. That is 8 centimeter. 8 plus 7, it becomes 15 centimeter. So while comparing x and z, the difference of height is 15 centimeter. The difference of the height of the x and z is not 7 centimeter, it is 15 centimeter is or 15 centimeter is taller than the z. So it is not possible. Therefore, it is not a transitive. Okay. Now, let us consider the question number D. The relation R such that x comma y such that x is a y of y. Okay. Now we will consider the condition one by one. The reflexive condition. X is wife of Y. Okay. According to the definition of reflexive, X is wife of himself or else herself is not possible. X is a wife of Y. Okay. X be an female. Y be an male. So it is not possible. It is not possible. Again, it does not hold. Second condition, X is wife of Y. Of course, the condition holds, but while taking exactly opposite, Y is not a wife of X because Y is a male person. He was a husband of X, not a wife. Therefore, symmetric condition does not hold. Similarly, for third one, transitive condition. Okay, transitive condition. X is wife of Y. Yes. Y is a male person. Y is while consider X comma Y. X is wife of Y. Again, while consider Y is related to Z, that time Y is not a wife because Y is a male person, is not wife to anyone. So it is also not possible. Therefore, the relation R does not hold any condition. Similarly, for the fifth condition, R is equal to X comma Y such that X is a father of Y. Okay. It is also similar to the fourth condition also. Okay. X is a father of Y. While checking the reflexive condition. Okay. While checking the reflexive condition, that is X is not a father to himself. Okay. X is not a father to himself. So, reflexive condition not satisfied. The person he is not a father to himself. Okay. It is not possible. Then, second condition, that is symmetric property. If X is father of Y, while considered in reverse order, Y is not father of X because Y is the son of X. Okay. X is father of Y means Y is the son of X. So it is also not possible. Next, a third condition, that is transitivity. Okay. Here, X is father of Y. Yes, it is satisfied. X is father of Y. Okay. Again, Y is father of Z. Yes, it is also possible. But why consider X and Z? X is the grandfather of Z. Okay. While consider the Z, he was the grandson. Okay. He was grandson to X. So it is also impossible. X comma Z is not related to R. He was the grandfather to him. Therefore, transitive condition is also not possible. You have to write in your sentence. Okay. Up to this much, I have solved the problems. After that, I will continue the exercise problems in next continuous session. Okay. If you really like my classes, please like, share, and subscribe my channel. If you have any doubt or else if you any doubt regarding the questions or else any other issues related to any problem, please write your doubt on a comment box and please share, subscribe my channel. Thank you everyone for watching my classes.